Hello, welcome again. We are solving some questions of fluid mechanics and machinery. The topic is viscous and turbulent flow. Question number 44 from GATE 2014 ME-01 is: in a simple concentric shaft bearing arrangement, the lubricant flow in the gap of 2 mm between shaft and bearing. The flow may be assumed to be plane of quart flow with zero pressure gradient. The diameter of the shaft is 100 mm and its tangential speed is 10 meter per second. The dynamic viscosity of the lubricant is zero point 0.1 kilogram per meter per second. The frictional resistance force in Newton per 100 mm length of the bearing is. So as the flow is quart flow, so general Newtonian law is valid for the flow. Okay. So this is the figure where this shaft rotates within the bearing, and this is the lubricant, and gap is your 2 mm. Diameter is 100 mm, and viscosity of lubricant is your 0.1 kilogram per meter per second, and velocity of shaft will be equal to or the velocity of the layer adjacent to the shaft is will be same as that of the speed of the shaft. Okay. So here, if there is layer of fluid, then its velocity will be equal to this shaft velocity. Okay. So, and here the layer adjacent to that bearing will have zero velocity. So the velocity is, so suppose this is your shaft and this is the layer adjacent to the shaft, and this is your bearing, and this is the layer adjacent to the bearing. So here the velocity is 0 and here the velocity is for du. So change in velocity is du, and that gap is your 2 mm. So Newton's law is valid. So according to Newton's law, tau is equal to mu du by dy, where tau is your shear stress, mu is your viscosity, and du is your change in velocity. And so here the velocity of the shaft is 10 meter per second. Tangent speed is 10 meter per second. Okay, so du is 10 meter per second, and dy is your 2 mm or 2 by 1000, or shear stress is 500 Newton per meter square. And as this is your shear stress, so the shear force is your shear stress into area. So that is, shear stress is 500, and area for the shear stress is tangential area, that is pi d l. L is this length, and diameter is this diameter, tangential area. Okay, because we have to find out shear stress. So that is pi d l. D is your 100 mm, 100 by 1000, L is your 100 by 1000. So shear force is your 15.71 Newton. So answer is 15.71 Newton.